Hi class, this is an example of point ratio form of an exponential function. What you see on the screen right now, y equals ab to the x, is the general form of an exponential, where a is the start value, b is the growth or decay factor, and x is the number of years or compounding or growth periods that you're going to have. It's typically years. In this problem, however, I don't give you the start value. Neither one of these points is of the form 0, comma something. If we knew 0, comma something, we would have the a value, but we don't. So what we'll do is we'll think back to our section on lines when we had slope-intercept form a plus bx. That came in very handy when we knew what the intercept, y-intercept a was. We had to go to this second formula when we didn't know what a was. Instead, we had a different point on the line called x1, comma y1. Where x1 was a x coordinate of the point that we knew, y1 was the y coordinate of the point that we knew, and b was the slope. With point ratio form, it's kind of similar to what we had with point slope form, but you have y equals y1 times b to the x minus x1. So the x1 is the x coordinate of one of the points that you know, and y1 is its partner. So it's a point on the curve. 2, comma 8, for example, will go in for x1 and y1. B is the common ratio, or the growth slash decay factor that we're trying to find. It's what we don't know in this problem. So what we'll do is we'll take turns plugging in 8 for y1 and 2 for x1. So the first thing you'll see me do here is write an equation with 8 substituted in for y1, b is unknown, x is unknown, and 2 substituted in for x1. Then in green, I'm going to take the other point, 5, comma 19, and put 19 in for y1 and 5 in for x1. There you go. Y equals 19 times b to the x minus 5. Now, since these two different equations, the blue one and the green one, are both equal to y, we can set them equal to each other. And that's what you'll see in the next line. Here we go. So I have the top equation, 8 times b to the x minus 2, equal to the bottom equation, 19 times b to the x minus 5. From this point on, we're going to try to solve for b. So the first thing we're going to do is divide both sides by 8. When you divide both sides by 8, you get b to the x minus 2, because the 8's cancel out, equals 2.375 times b to the x minus 5. The 2.375 comes from 19 divided by 8. Now the next step is really what's unique about this type of problem. You're going to divide both sides by b to the x minus 5 in order to get the b to the exponent, those two pieces, grouped together on one side of the equation. Watch how this plays out. On the right side, the b to the x minus 5s will completely cancel out, leaving us with 2.375. On the left side, we're going to use the rules of exponents that we learned. When you have the same base raised to a power over the same base raised to a different power, you subtract their exponents. I'm going to skip ahead so you can see what that becomes. On the left, you see some scratch work just showing you the formula or the rule that I used here. And then you see x minus 2 minus x minus 5. I'm showing you that the x minus 2 is like the m in this rule, while the x minus 5 is like the n. Now when you subtract these, again, I'm going to skip ahead. I won't skip ahead, just take a look at this. You have to do x minus x, and the x's cancel out. Then you do negative 2 minus negative 5, which is 3. So this left side becomes b to the third power, and the right side is 2.375. Finally, you take the cube root of both sides, and you get b equals 1.334. So that's going to be your growth factor for this exponential growth problem.